In this video, I'm going to show you how to write formulas from names of compounds using a method called the Criss-Cross method. Here are some rules to follow when writing formulas for ionic compounds. Formulas always have a positive and a negative part, so we're going to take a cation and combine it with an anion to form an ionic compound. And we always write the cation, or the positive part, first. So cation first, anion follows. Chemists do not write the number 1. We understand that because the symbol is there, that automatically tells us that there is one of that atom. If there is more than one of the atom, then we'll add additional subscripts, so 2 and up. Formulas use whole numbers only, so we're never going to see anything like H1.5O5. It would have to be H2O. We have to have whole numbers. Formulas are simplified and they're reduced when possible. And then when we're using a polyatomic ion, if we have more than one polyatomic ion, we're going to use parentheses around the polyatomic ion. So for example, if we're dealing with nitrate, which is NO3, and there's 2 of them, we would put the parentheses around the polyatomic ion, and then we would add the additional subscript outside of the parentheses. Formulas will have no overall charge, which means that if you combine the net positive charge with the net negative charge, you should overall have 0 charge or no charge at all. When we write formulas, there is a 4-step process we need to follow. Step number 1 is to write the positive part first with the charge and the negative part second with its charge. So if we were trying to write the formula for magnesium oxide, we have magnesium, and it has a symbol of Mg and a charge of +2 that's going to combine with oxygen, which is O, and has a charge of -2. We know what these charges are based on the location of these elements on the periodic table. In step 2, we're going to cross the charge number only. So we take the charge number from the superscript, so in magnesium that's the +2, and what we're going to do is we're going to move it over so that it will become the subscript for the other element. So our +2, we leave the plus alone, we're only moving the 2, moves over to the oxygen to become a subscript. So we're moving it from the attic to the basement, and the 2 from the oxygen moves over likewise to become the subscript for the magnesium. So we're crisscrossing. This is where the term crisscross comes from. We take the superscript from one and cross it over to become the subscript of the other. And we do that for both ions, the positive and the negative. And again, make sure you're only moving the number, not the charge. The plus and minus do not move at all. Step 3 in writing formulas is to erase the original charges. So from the previous screen, we had the 2 from magnesium crossing over to become the subscript on oxygen, and the 2 from oxygen crossing over to become the subscript for magnesium. And you can see by doing this, we have 2 magnesiums with a +2 charge, which gives us an overall +4 charge. And we have 2 oxygens that both have a -2 charge, so overall we have a -4 charge. So our +4 charge cancels out with our -4 charge, and that's why ionic compounds are neutral. But now, in our next step, what we want to do is erase the original charges. So we're going to get rid of this, and we're going to be left with Mg2O2. The final step is to simplify. So we're starting with Mg2O2, and our subscripts are 2 and 2. Can both of those numbers be divided by a common factor? And the answer is yes, they can both be divided by 2. 2 divided by 2 is 1, and I already mentioned as one of our rules that chemists do not use the number 1 as a subscript, so our final formula will be MgO for magnesium oxide. For our next example, we're combining aluminum and hydroxide. So aluminum is Al, and hydroxide is OH. Aluminum, if we look it up on the periodic table, has a +3 charge, and hydroxide has a -1 charge. Now keep in mind that hydroxide is a polyatomic ion, so the -1 charge applies to the entire OH structure. Step 2, we're going to cross the charges. So I'm going to have Al3 cross over to hydroxide, and the 1 from hydroxide cross over to aluminum. So I end up with Al1 OH3. Okay, what's wrong with this? Well, a couple of things. First of all, chemists don't write a 1, so I'm going to get rid of that. Second of all, hydroxide is a polyatomic ion, and I've added a subscript. If I were to leave this formula alone, it would say I have 1 atom of aluminum, 1 atom of oxygen, and 3 atoms of hydrogen. But that's not what we have. We really have 1 atom of aluminum and 3 hydroxide groups. So what I need to do is add parentheses around the OH. So now I'm going to reduce and simplify. I don't need the 1 because I don't write subscripts of 1. So my final formula will be AlOH in parentheses with a subscript of 3. Here's another sample problem. Combine tin 4 with oxide. Please pause the video and fill out your answer, and then check to see if you're right. Since we already have the symbols written, what we want to do is crisscross our charge numbers only. So I'm going to cross the 4 over to the oxide and the 2 over to the tin. And when I do that, I get SN with a +4 charge with a subscript of 2, and oxide with a -2 charge with a subscript of 4. Next, I'm going to get rid of my charges. So I'm going to be left with SN2O4. My final step is to simplify. Can 2 and 4 be divided by a common number? And the answer is yes. They can both be divided by 2. 2 divided by 2 is 1, and we don't write ones, so I'm just going to write SN for 10. 4 divided by 2 is 2, so I have O2. My final answer is SnO2. In this example, we're combining magnesium and phosphate. Again, please pause the video and solve the problem on your own, and then check your answer. We need to start by figuring out the charges. Magnesium has a charge of +2, and phosphate has a charge of -3. When we crisscross, we're going to end up with our 2 coming over to the phosphate and our 3 coming over for the magnesium. So we end up with Mg3PO4 2. Now because I added this extra subscript, I need to make sure I go back and add parentheses around my polyatomic ion. Can 3 and 2 be divided by a common factor? The answer is no. So my final formula is Mg3PO42. This is your last practice problem. Cross ammonia with carbonate and see what you get. Please pause the video and work the problem out yourself, and then check your answer. The charge on ammonia is +1, and the charge on carbonate is -2. Now that I know the charges, I can cross my numbers. So 1 comes over with carbonate and 2 moves over with ammonia. That gives me NH4 with a 2, CO3. Because ammonia has this added subscript of 2, I need to go back and add parentheses around ammonia. I don't need parentheses around carbonate because I didn't move another number over there. Since I don't write ones, I didn't add another subscript, so carbonate does not go into parentheses. My final answer is NH42CO3.